Hey everyone, it's Cameron from EMCO Applied in New Brunswick. Today, I'm revealing an innovative hot water solution that's poised to change the way we heat multifamily and commercial buildings. You might have heard a shocking stat that one gas boiler can produce the same carbon emissions as 7 transatlantic flights. Well, now you know. That's wild, but it also means that there's a huge opportunity to save energy, cut costs, and slash emissions. And trust me, if you're a contractor, developer, or construction manager in Atlantic Canada, or anywhere else for that matter, you'll want to hear about this. Let's get into it. Right now, in both the United States and Canada, fossil fuel bans and sustainability goals are pushing for cleaner, more efficient heating methods. In new builds, retrofits across the board, we're seeing a major shift. Gas and oil boilers are under scrutiny because they're large, complex, and producing a surprising amount of CO2. That's why I'm constantly on the lookout for products that can replace these old school systems without compromising performance. Enter the Daikin MegaQ. As the Daikin Applied rep here in Atlantic Canada, we are very excited to see this all-electric, heat pump-based hot water system that's designed to tackle the CO2 challenge. Instead of burning fossil fuels, it taps into advanced heat pump technology, delivering reliable hot water and helping slash carbon emissions. And here's a cool fact. This system has been proven for over a decade in Japan and is now finally here in North America. In other words, we're getting tried and true performance in a brand new market. Now that we are a few minutes in, I should let you know that this is a wide overview of the solution, not so much a technical deep dive. If you are in the Atlantic Canada market and would like to get more technical, please reach out by email and we can schedule a call. I will highlight the technical specs now. Each MegaQ is 120 MBH, which is a 10-ton system, and you can hook 6 together on a single water loop for a total of 720 MBH. That means more than enough output for large multifamily residences, hotels, and commercial buildings. And it does look very similar to the VRV units that we are using right now. The control logic in these systems is incredibly sophisticated. Unlike a standard hot water setup, the MegaQ uses 3 different sensors inside the storage tank, each one reading a different layer of water that lets the system precisely control how much heating is needed at the top, middle, and the bottom of the tank. The result? Fewer spikes or drops in hot water temperature and less wasted energy heating water when you don't have to. This system operates in ambient conditions from 4 degrees Fahrenheit to 109 Fahrenheit, delivering hot water temps of up to 194 degrees Fahrenheit. Oh, and if you are in a region with energy efficiency programs and rebates, this system boasts COPs up to 4.6, giving you significantly better efficiency than your typical electric or gas boiler. Think about that difference in the long term in an operation scenario. Next, there's the built-in inverter-driven water pump in the Cascade unit. Typically, you'd have to spec out a separate circulation pump and do a bunch of guesswork to size it properly. With the MegaQ, the pump is already integrated and it automatically adjusts flow rates. That means fewer external components to install, faster commissioning, and hopefully smoother, more reliable operation over the life of the system. Now, one major advantage that often goes overlooked is the inherent redundancy when multiple MegaQ units are installed on the same loop. If you're in a large building and you want extra peace of mind, you can set up more than one unit, so if one unit ever needs servicing, the other can keep delivering hot water. That is a game changer in critical applications like hotels and apartments and assisted living facilities where downtime is just not an option. For install, the outdoor heat source unit can be placed up to 65 feet away from the Cascade unit, which can either go inside or outside. And this potentially frees up a lot of space and opens up some design possibilities, especially in challenging sites. Another big highlight is the advanced defrost strategy in colder climates. In a typical heat pump system, you might see a performance dip or frequent cycles when temperatures drop. Here, the outdoor unit uses a specialized defrost logic that cuts down on the downtime. It kicks in only as needed, and each outdoor unit in a multi-unit setup is smart enough not to trigger defrost at the same time. This means your hot water supply stays consistent even in harsh weather. Finally, there's a huge win on the maintenance side. You're not dealing with fuel lines, combustion exhaust, or complicated venting. You don't have to do routine flue checks or worry about carbon monoxide alarm. All those headaches vanish when you switch to a fully electric heat pump setup. And by eliminating those extra plumbing and safety considerations, you simplify compliance with new regulations while lowering your total cost of ownership in the long run. I'm speaking generally about regulations, but as you know, the building code and different regions put this all together: precise temperature control, integrated pumping, built-in redundancy, intelligent defrost, and simpler maintenance, and you've got a commercial hot water solution that really pushes the envelope. Don't just take my word for it. Daikin currently has pilot projects in New York City, and they've tested these systems through freezing temperatures, and some even added backup electric heaters inside the storage tanks, which they never even needed to switch on. That's reliable performance with tangible data behind it. So if you're based in New Brunswick or Nova Scotia or Prince Edward Island, and you've been hit with questions about electrifying domestic hot water or needing to replace old boilers, this is a game changer that you can confidently propose. Let's zoom in on exactly how the Daikin MegaQ generates hot water so efficiently. Picture two refrigerant loops working in tandem. First, we have the heat source unit outside. It circulates R410A refrigerant, just like a VRV air-to-air heat pump. By absorbing heat from the outdoor air, even when it's super cold, it circulates a stream of high-temperature R410A. This stream then flows into a cascade unit, which is where the magic happens. Inside the cascade unit, that hot R410A transfers its heat to a second refrigerant loop running R134A. The cascade unit is equipped with its own compressors that boosts the temperature of the R134A even further. From there, a built-in heat exchanger uses the R134A to heat the water you're sending to your storage tank or your secondary heat exchanger. Essentially, it's a step-up system. The first loop raises the temperature and the second loop raises it even higher, up to 194 degrees in some scenarios. The key element here is the tank controller kit. As I mentioned, this includes 3 water temperature sensors that you place on the top, middle, and bottom of your water storage tank. By reading these different temperature layers, the control logic knows exactly when to ramp up or down those compressors and how fast or slow to run those integrated water pumps. You're not guessing about water temperature, it's monitored in real time, which leads to more consistent hot water delivery and better energy efficiency. The split design is another game changer. The heat source unit and the cascade unit can be installed up to 65 feet apart, horizontally or vertically. That means if your building doesn't have space for both pieces side by side, you can tuck the cascade unit indoors where it's warmer and less exposed while the heat source unit stays outside, or you can put them both outside, whatever suits your layout best. Finally, if your end goal is domestic hot water for an apartment building or a hotel, it's easy to keep everything code compliant. You typically install a field-supplied secondary heat exchanger or an indirect storage tank, so the R134A loop never mixes with your potable water. That's it. 2 refrigerant loops, a smart controller, and a flexible installation that let you swap boilers and slash carbon emissions, all without sacrificing performance. So there you have it, Daikin MegaQ, a proven heat pump hot water solution that can help developers, contractors, and construction managers meet increasingly tough decarbonization targets without sacrificing performance. If you'd like to learn more and dive deeper in discussion for a specific project, please feel free to reach out to EMCO Applied, as we represent Daikin Applied and Daikin North America in New Brunswick, Prince Edward Island, and Nova Scotia. We're here to help you find the best fit for your buildings. Trust me, you don't want to wait until regulations force your hand. You want to get ahead of the curve now. Thanks so much for watching, and feel free to reach out with any questions.